Hi viewers, welcome to Imperial Chemistry. Today we are going to discuss an important topic of first year chemistry from Unit 2 Atomic Structure. The topic is discovery of electron or discovery of cathode ray or discharge tube experiment. So this all started from John Dalton atomic theory. John Dalton in 1805 considered that all matter was composed up of small particles called atom. He visualized the atom as a hard, solid, individual particle incapable of subdivision. At the end of 19th century, there accumulated enough experimental evidence to show atom is made up of still smaller particles. These subatomic particles are called fundamental particles. The discovery of these particles proved to be a limitation of his theory. These discoveries were made possible through experiments like discharge tube experiment, which revealed the discovery of electron. So what is discharge tube? It is a glass tube with two metal electrodes, cathodes and anode. Cathode is connected to negative terminal of the battery and anode is connected to the positive terminal of battery. The tube is filled with a gas, air or vapor of any substance at any desired pressure. So the tube may be studied at low pressure, so we have connected a vacuum pump. The two metal electrodes are connected to high voltage source. As you can see here, this is the glass tube. There are two metal electrode, anode and cathode. Anode is positively charged, cathode is negatively charged. Here we have applied high potential difference of 5000 to 10,000 volt. The gas inside the tube is inert gas, for example, hydrogen or helium. There we have vacuum pump. This vacuum pump is used to reduce the pressure of gas inside this tube. The wall opposite to cathode is coated with fluorescence material, for example, zinc sulfide. So when we will apply high voltage here, the gas will be ionized here and the electron, or you can say the cathode rays. At that time they called it cathode rays. They didn't know that these are electron. So these electron will go and will pass through these porous holes, or you can say these electron will go toward the wall that is coated with fluorescence material, and this will glow. The glow may depend upon the color of fluorescence material. So what William Crook observed? William Crook observed that gas inside the tube at ordinary pressure do not conduct electricity, but under low pressure electricity can pass through the gas and produce spark. When the pressure inside the tube is reduced to 0.1 mm Hg, a soft uniform glow appears inside the tube. In the presence of high voltage 5000 to 10,000 volt, an electric discharge takes place. As a result, uniform glow inside the tube is appeared. When the pressure is further reduced to 0.01 mm of Hg, the glow vanished, it disappeared. The whole tube is filled by dark spot spaces and no luminous discharge is observed. Under these conditions, some ray were produced, which produces fluorescence when strike the opposite wall of the tube towards the anode. The ray were called cathode ray by Goldstein because they move from cathode towards the anode. What J.J. Thomson did in 1897, he refined Crook cathode ray experiment. He said that these cathode rays were made up of negatively charged particles. He measured the charge to mass ratio. He identified these are the fundamental components of atom. The term electron was then coined by Stoney in 1891, and J.J. Thomson was awarded a Nobel Prize in Physics in 1906 for his work on electron. Next is the properties of cathode ray. Thank you for watching. Subscribe for more exciting chemistry tutorials.